Hey everybody, so we thought we'd make a video about how to actually manufacture products, not just because we do a lot of manufacturing, but how to make stuff in general outside of 3D printing. And while I was setting up this video, I saw that the floor was like this, and I saw our broom right back there, so I'm just gonna go ahead and sweep the floor while we're doing this. So manufacturing generally tends to be very difficult for people because quite frankly, it is very difficult. Manufacturing is not one of the easy tasks or businesses that you can start up at any given time when making something. And the reason why this is just because manufacturing is very complex and multifaceted in a way that people don't recognize, and hopefully I can give some clarity to in this video. But when you're wanting to manufacture a product, what you have is a tremendous challenge of organizing dozens, if not hundreds of different people and getting them all to do each one of their jobs perfectly correctly. And this is just very, very hard. But let me whine about that a little bit later. Here is how you would get a product manufactured. The very first thing you need to do is to make drawings. And these are not technical drawings, these are not CAD drawings, these are not engineering drawings. These are what some people would call napkin sketches. Napkin sketches are not what I'm talking about. Napkin sketches are great when you're trying to think of the idea. They are absolutely useless when you try to manufacture it. When I say drawings, I mean a detailed description of the item. This means what the dimensions are, what size it is, what it's meant to be used for. This is a description of your item, and you're gonna describe it as completely as you can to yourself in as many different ways as you can and in as much detail as you possibly can. If you can, you select the material, you lay out the dimensions, you describe who the person is who's using it, just everything you can possibly imagine. In a perfect world, you have already sold to some customers or have some pre-orders. So you have this concept laid out already because you made a product and you found out if somebody is willing to buy it. And just to emphasize this, you should not start manufacturing an item until you have somebody who bought it, or you should at least, very least, have just sort of semi-planned out manufacturing until people have actually bought it, because this process is expensive, and if you want to prepare ahead of time, there's no reason to prepare a product that no one has bought yet. But okay, you have a proven product and people are willing to pay you for it, or you're pretty sure people are willing to pay you for it, so now you are getting it described. This is something that is detailed enough to where now you can hand it off to a designer. Now, admittedly, most of the people who create some sort of product are very often engineers. If you're designing a physical thing, you very often have some background in physical creation where you're working with it. So you're a machinist, you're an engineer, you're something else along those lines, and you are going to be able to create many of those drawings and the technical details about it yourself and understand what the context is. If you are not an engineer, you need to educate yourself. You need to become fascinated about how your part is made, because if you think you're going to outsource the decision making, your product very likely will not succeed, especially in the early stages when you have nothing about it. The way to ensure that your product succeeds and has the highest chance of being manufactured reliably is to have an informed opinion, or at least clear lines of what can and cannot occur. You need to spec it. You need to be like, it needs to sit in this place, hold this much weight, be these dimensions, whatever it happens to be, and then work backwards from that. The reason this is so important is because if you do not have a detailed vision in your mind of what it should be, then the manufacturer is going to be useless to you, and they will suggest things that are cheaper, faster, better, different, worse, whatever it happens to be, and based on what their incentives are, and will not create what you want your product to be, and it can end up being watered down at the end of it all. Okay, so you have created a spec sheet. You have described your item in tremendous detail so that if some situation arises where people are like, oh, you want it made out of wood, well, can we make it out of plastic? You can say yes or no to that question. This is what's so important. So you have now created a spec sheet. You can now take it to an engineer or a designer, and they will be able to design the thing for you, and you will be able to set the conditions by which that design should be created and when they have met the spec. The spec sheet is going to describe what the item should be so that if the person does not deliver the design, you don't have it right. You are not required to pay them for that design. And you will say it in every context. If it does not meet my spec, then the job is not yet complete. This is the condition for completion. If you have fulfilled everything on the checklist for these specs, the only way you can do that is if you have a checklist. All right, now a designer has created a design, and that design will be a 3D model. You want it as a step file, and you want the designer to give you the step file for it, along with the original CAD files when you start designing it all. You want all of that. The original CAD files might be Autodesk, SolidWorks, something else like that. The step file is an engineering file that can move between all of those softwares. And just for good measure, you should have it converted into an STL just to save people work down the stream, in case you happen to ever have it 3D printed in a place like this. All right, so now you have files of your design. Now you can proceed to find a manufacturer. Where do you look for a manufacturer? If you're okay with China, you can go to Alibaba.com, at which point you will look up items similar to your own. You will say, oh, I'm making a funnel. I'm gonna look up funnel companies. And then you'll find a funnel company, and then you will contact them through Alibaba and say direct message seller, and you will say, hey, would you be interested in manufacturing a custom funnel? And they will say, yes, no, maybe so. Who knows what it all is. If you don't want to work with China, then the thing you need to do is go to thomasnet.com or mfg.com or one of those similar sorts of ones and have them give you the option to buy one of these things. If you do not want to go to China, then you need to go to thomasnet.com, and then you will look up manufacturers in your area. You will say funnel makers, injection molders, 3D printers, those kind of things, and they will list those manufacturers. Or you need to have been researching so much stuff about your product before this. Instagram and Facebook and TikTok and all the rest of them will funnel you towards the people that you need. This actually happens way more often than you might realize, like literally even this video. You may have gotten this video because you have been looking for how to manufacture stuff. So that is the internet gods working to help you. So literally, if you share a little bit of information about what you're working on, they will help you. Okay, so now you've gone to Thomasnet or Alibaba, you have contacted the manufacturer, and they have responded to you and said, sure, send us over your request for quote, an RFQ. An RFQ is a thing where you detail your project. We go back to your spec sheet again. What does it need to be and what do you need to do? You need to tell the manufacturer your budget, what materials, what quantity, and a non-negotiable specification. Negotiable specifications are things like cost, lead time, maybe even material. Can it be redesigned? Those might be negotiable. The non-negotiables are, I'm making a funnel. Well, can we make you a pipe? No. You cannot do that. That is not a funnel, and this will happen. Other non-negotiables are very often things inside of dimensions. So what is a critical dimension that has to have this variation inside of it? Otherwise, it's not functional. It has to have this part press fit into it. If it doesn't press fit, then the bearing falls out and the thing is useless. Those are non-negotiables where you tell the manufacturer, this has to be this way, otherwise it doesn't function. You have to write those out and you need to put them on a list so the manufacturer knows and they can decide, can they make it or not? This is now where you're working with a manufacturer, and I want to emphasize this for a moment here. Manufacturers are investors. If you want to work with a manufacturer, you have to convince them to work with you. There are a lot of people making stuff, and there are a lot of entrepreneurs who are trying to invent something. And the problem with entrepreneurs who are trying to invent something is that you are very likely going to go broke. This is mean and terrible and scary, but if you are scared by this reality, you need to stop right now, because 90% of new businesses fail in their first 2 to 3 years. So why should manufacturers invest time, effort, money, resources, discounts, net 30 terms, which are basically a loan, if you have a high probability of going broke? The way to communicate that confidence is to be prepared and be decisive. Have a spec sheet, have non-negotiables, and understand your stuff well enough to where you don't just say, here's a napkin sketch that somebody gave to me. I need 10,000 of them because I think it's gonna catch off. And by the way, they need to cost 25 cents a pop. Figure out how to do that. The manufacturer will ignore you. And this is actually a very easy way to define if your product is ready or if you are ready. If manufacturers of all types are ignoring you and not engaging with you, you are unprepared. And in this world of AI and ChatGPT and everything else, you should not be unprepared. You should discuss your project with ChatGPT and say like, okay, I'm working to make this funnel. How do I go about it? And it'll guide you through it and give you some expertise and some pointers and some baselines. And you can talk to it as if it is your tutor, and you can learn things so that you can be somewhat competent when discussing with manufacturers. Certainly, manufacturers should help you and should be available to discuss things and give fine details, but they are the upper echelon of expertise of how to make the thing. They do not want to explain how injection molding works to you in order to get started. There should be some baseline understanding of this, of like, oh, I want a mold to be made and I want the mold to cost $200. That's just a non-starter because you are so far away from the reality of what it takes to make this thing that they just can't engage with it. And they're like, this isn't even worth it. This person is too much of an amateur. But again, the way to fix this is to be very concise about what your item is, have a design that is to your spec and is detailed, and understand what the non-negotiables are. That is the most important. Everything else that is negotiable, the manufacturer can use to help meet your spec better. So if you have unlimited budget, the manufacturer can be like, okay, do you want it next week? No. Well, you have unlimited budget. You can get it faster. Well, I don't need it faster. I need it in 3 months. Okay, well then the cost will be this. This, by the way, the budget is often one of the easiest way to identify someone who is non-serious or an amateur. And I recognize the fact that I am saying this as a manufacturer, so there's a little bit of bias here. But this is really important to understand. You have to share your budget. Share your budget with the manufacturer. Tell them what cost per part you need, what the maximum lead time is, how much money you have available. These are all required for the manufacturer to understand if you're serious and capable of getting this done. And it will save you so much time and the manufacturer so much time. If you call someone up and say, we need to make this for a penny a pop, they may hang up on you bluntly, but at least you know that they weren't a good fit. And then you didn't go through 2 weeks of quoting and back and forth just to find out that they're gonna quote it $1 and you want it for a penny. So just tell them, we need it for a penny. And if that's the critical thing, tell them, we need it for a penny. What can we do to start getting close? In this situation, the manufacturer can then say, okay, well, we gotta get to a penny. Well, can we extend the lead time? Because if we can produce it over a slower period of time, then like in the case of a print farm, we can use excess capacity, which is kind of free because it would have been unused. So we can produce it here in between other real projects. Or, okay, you wanna get to a penny? Well, can we redesign it so it's no longer what your current design is? And this is why it's important to have the non-negotiables, because if you wanna find the solution, you have to know what constraints are absolutely required and which ones can be moved around to get to some other main thing. Can you change the design if it makes it cheaper? Can you extend the lead time if it makes it cheaper? Can you just pay a little bit more and get better quality? Those kind of things. Quality is a very good discussion to have. Quality is not what people think it is. People think quality is defined as good. Good does not mean anything. When you are manufacturing something, you need to have engineering quality. Engineering quality is defined by tolerances, surface finishes, and quantifiable measurements of the part. If we are making a part, some client will tell us that this hole needs to be this size and it can be plus or minus 0.5 millimeters or something, 0.1 millimeters. If we make a part that is plus or minus 0.2 millimeters instead of 0.1, that part is low quality because it does not meet the spec of the part. In aerospace, low quality is 10,000ths of an inch. 1,000th of an inch can be out of spec in aerospace. In fact, 100,000th, a millionth of an inch can be out of spec in aerospace. In 3D printing, rules are a little bit different. Good here is a little bit different from good in aerospace, which is a little bit different from medical products, which is a little bit different from toys, which is a little bit different from this. This is, again, going back to the non-negotiables. What does good mean to you? And by the way, I fully realize that all of this is wildly pedantic and frustrating because it is a tremendous amount of paperwork and documentation. I agree, but it is the only way to ensure that the parts that you order are the parts that you intend. You have to describe them in tremendous detail and say what you need. The very best way to get the worst quality parts is to be in a hurry without a set budget. You say, I need 5,000 parts next week. I need them whatever, hook or crook. Then you had better be ready for a large number of those parts to be out of spec because there is not enough time to go through certification and qualification. So let's talk about certification and qualification. You just got a quote for your part, but you're not completely done yet. In our case, and it can vary from factory to factory, next you will need to do a prototype. A prototype allows the manufacturer to learn about your part without having to, a prototype allows the manufacturer to learn about your part for the very first time because they have never seen it before and they've never seen it in the real world before. They can look at the design and most of them will be able to see most of the things that will go wrong, but until they do a prototype, they won't realize, oh, there's this weirdness. It could be a feature that's too small to spot. It could be that your material doesn't actually work with that geometry of the part. They could find out that you're a really needy client who needs updates every 15 minutes about how the part is going. But this is what the prototype does, is it's basically sticking your toe in the water and showing the manufacturer that you're serious enough to order a prototype so they know that you're serious enough to actually order the actual batch of parts. That prototype will come out, but very often it won't be ready for manufacture yet because the manufacturer will have kind of shoved it through, maybe shortcutted some stuff, maybe duct taped something up, made it work for that prototype in order to help get the deal, but then the part may not be fully ready for production yet because there's optimizations to be done inside of the process. But you get the prototype, it's pretty good. Now you're ready to move into production. On the production side, you might order 10,000 parts. A manufacturer should make like 500 to 1,000 of those parts and then send them to you so that you can go through and review them. This is where you will find all of the edge cases because you wrote up your spec doc of all the non-negotiables and that certain statements stains don't work and certain dimensions are important. But when you start manufacturing, you're gonna discover a whole world of other things that go wrong. This is, again, you find out that it shrinks a little bit, or that it warps in a car, or you give it to a customer and some baby swallows it, or something like that. Discoveries will be made. At this point, the part may have to be revamped, redesigned, or the process changed, or the manufacturer will have to update their sheet of things on the checklist. This could potentially change pricing, but most manufacturers will have it baked in because they know that this is going to happen. So they should be able to do updates on the fly throughout here. Again, something that we definitely do here inside our print farm. Once that first 1,000 parts are done and the manufacturer's gotten like below 5% shrink or so, then it's ready to go into bigger production. At this point, it's pretty much process optimization. So for that mass production run of 10 to 100,000, the manufacturer will be doing all the work internally to make sure stuff stays up to spec. Your job is to continue to inspect the manufacturer. Though at the same time, to be reasonable, and again, an identification of an amateur is professional clients recognize that they will have a 1 to 3% shrink rate on all parts. A shrink rate is the parts will go wrong somehow. They will get run over in UPS. They will be out of spec. Something will go wrong. If you want to hear about shrink rate, by the way, Sandy Monroe of Monroe Live, a different YouTube channel, did a video at the Tesla Cybertruck factory, and the head of that program was talking about how many panels from the Cybertruck were going wrong and what their shrink was, and how many spools of steel from the steel foundry were defective or unusable. And they were talking about a 2 to 3% shrink rate at that time. So as the customer ordering the parts, you have to expect that a certain number of the parts are just going to go wrong. Retail has to deal with this with people stealing stuff from stores. Online retail has to deal with this with people returning things. Manufacturers have to deal with defect rates. The inventors have to deal with the defect rates. But now you have something that is manufacturing. And what you have done by going through this entire system is you are going to feel like, oh, I've just made 1,000 parts, but that is not what you have done. In reality, what you have done is you have built a manufacturing system. You have built a company. You have built specs for your products. You have a manufacturer who is qualified and verified, and you have the products in stock and working so that if you need to order another 100,000, you can do that. You are building a business. Welcome to the party. You have now gotten further than most people because most people can't get the first parts even made because they fail out in all of this qualification because, quite frankly, it's a chore and it can be expensive because the worst thing that you can do is go to a manufacturer and try 3 to 4 guys all in parallel and they all go wrong on you. You have to build this into the budget when you're doing it or decide on technologies that give you more flexibility. 3D printing can go lower volume. Injection molding can be more reliable long term. It can also be more reliable if your part is ready. Is your designer able to design for injection molding? These are all the factors of doing it. Manufacturing is complicated, tough, and has a lot of different factors inside of it. So now you have the first 1,000 to 10,000 parts produced, and you have a manufacturer who's qualified to produce more of them for you. Congratulations, like seriously, good job. You have gone to Alibaba or Thomasnet, you have found a manufacturer, you have reached out to them with a detailed spec sheet and specifications of your project, sharing the budget so that they are able to accurately quote you and understand that you are for real and understand the context of what you're dealing with. And you have gone through prototyping, qualification, final engineering designs, and you now have 10,000 parts sitting inside of your garage. Fantastic. And since you were listening at the beginning of the video, you already have pre-orders for this item, which you can do by basically setting up a listing for the product, saying, hey, we're working on manufacturing this, pay us $1, and when we get this made, you can buy it from us for $25, and we know that you at least put your money where your mouth is and you love this product. And now when you got your 10,000 items, you know that there are people there ready to buy them. Not all of them will buy them. Not everybody who pre-ordered it will buy it, but you are ready. And there's no way that you can potentially screw people, but you get people to prove out that they're actually into it. So this is why it's so important to sell the thing before you get there. Another way of selling the thing before you get there is to call up the company that you're making some widget for and say, hey, I've got this awesome toy. Generate some images of it in AI, see if the buyer's like, I would definitely buy that if you get that ready. Be really transparent about the fact that you're like, I'm setting up manufacturers for this, I'm gonna get it made, and they will say, great, if you make that, we will buy it. And you can have them sign a letter of intent, and that is not a purchase order, but it is better. And if you can get them interested in it from just baseline kind of conceptual drawings, then you can get somebody else interested if they bail on you for some reason. But it is so important, guys, to make sure your item is sold before you go down this entire rigmarole of getting it made, because getting it made is hard and you need to know that you have a result at the end of the rainbow. So either have really good market knowledge, really good understanding of the problem, or anything else. If you are an established entrepreneur, you know all of this stuff. You can recognize when there's actually an opportunity and you're like, I'm gonna make this widget, it's gonna save this person 10 bucks and I'm gonna sell it to them for 2. They're definitely gonna take it because I know Mike over there and he'll give me a meeting and I'll explain it to him and he'll know that that'll pencil. That's an easy way to solve a problem, is that the math just works. But if you're making a toy or a widget or an invention, there's tougher ways to make the math work because you now have a marketing problem. But with the internet and the communication tools that we have right now, it has never been easier in history to get a part qualified and get sales out there. There are kids in college who are doing TikToks about how to make a water bottle, who then are able to get pre-orders for that water bottle because people watch them on the journey. Share the journey. Hopefully this was useful to you guys. This is kind of give you the context about how to make a part. We have mass produced millions of parts over the last few years for thousands of different clients, from Fortune 500 down to entrepreneurs. And it is so important that people understand kind of the process as a whole so there's clear expectations for it. Because many people have a misunderstanding that manufacturing is you upload a model and then you print it. And while we work on that kind of stuff with our apps like Portals and Teleport, it is very difficult, and even there it is necessary to verify a design and get it run out. And if I could leave you with one final thought here, it's don't be scared. The entire thing that I just described right now could be very difficult. But again, there are so many resources available to help you out and many places that will explain how to help it out. That's literally what this channel is about. You also have, again, the AIs, the ChatGPTs, all these things that will help you along the way. You have to use them though. And you have to be open to asking questions. The most dangerous thing you can do is protect your idea and hold it close, because that radically increases your rate of failure. Here's an interesting statistic. Of all the clients that we have had over the last 7 years of operations of doing this kind of stuff, nearly every single client who has ever asked for an NDA has not turned into a real customer. The vast majority of those clients were independent investors or independent inventors or entrepreneurs. But whenever they asked for an NDA, our sales team basically just said they asked for an NDA, they're never going to turn into a customer. After like 5 years of us signing tons of NDAs, that was the thing. And while we still sign NDAs, we're just like, oh, this guy's a dud and he's dead. It's not going to turn into anything. We have had multi-million-dollar clients never have us sign an NDA. They don't care because they're doing everything else. The ones who sign the NDA are generally looking for some way to find an excuse to make it harder on themselves. Make it easier for yourself. The way you make it easier is share the budget. The manufacturer doesn't care. They're not going to screw you. Yeah, they might spend the whole budget. Fine, that's what your budget was there for. Don't go over, that's the thing. Or the manufacturer will quote you lower because they're like, oh, this is their budget, I'm gonna quote under because I really wanna help these guys and I wanna win them over. So the sales guy's gonna be like, we're gonna come in under budget. So don't play the game. Don't try to hide information. Be as forthcoming and open as you possibly can, because then people will be forthcoming and open with you and more opportunities and solutions will come out. Literally, if you're worried that someone's gonna steal your idea or anything else, number one, quite frankly, you're just objectively wrong. The theft stories are kind of like the stories of razor blades and apples. They're a good legend, but they're really not that common. Even if you send the item over to China, China's not gonna steal your idea unless you're already selling thousands of them. So you don't have to disclose your sales numbers, but you also need to be open about how many of them you need and what your item is. Because if you're not going to share your quantity and you're not gonna share your budget and you're not gonna share your designs until an NDA is signed, you're officially just a diva, and manufacturers have other people to work with who are easier. And it's difficult to work with somebody who doesn't want to share any information. So if you want people to help you, you need to be open and honest and forthcoming with as much as you possibly can so that people can help you along the way. Because most people have their own stuff going on anyway, and they don't want to copy your idea unless your idea is so grand and they have the mold in the back already. Even injection molding companies are not going to be like, oh yeah, we could start selling these funnels. No. They're making injection molds. They don't know anything about how to sell funnels on Amazon. That's your job. Go build that business. So if you're looking to have a product to be manufactured, make sure that you're just very, very open and not being secretive, because all of that feedback when you were brand new is so useful. The very best thing that can happen is somebody tells you that can't be made because they saw the design over your shoulder and they're just like, that won't fit in a mold, that won't print on a printer, and then you saved yourself a whole bunch of time and effort making something that just won't work. So get it out there into the world as quick as you can. Once you're big and established and rolling and getting sales, then you can start to be protective because you have something to protect. But when you have nothing, there's nothing to lose. So be as open as possible and go out there and start grinding through it. Manufacturing a product is a fantastic thing to do and is so incredible when you get it done. It's so neat to see the things that our clients and customers create all the time. But there's so many people who don't create it. And that's what I got to say to that. Not to undercut the gravitas of this whole thing, but if you have a new product that you're trying to get verified sales for, you should probably create a 3D model for it and upload it to portals and then see if anybody buys it. And just like lose some money on it the first time around. If you gotta sell it for $5 and it costs $6 to make through print on demand or something, do that, because at least then you know if somebody's selling it. This wasn't meant to be a shill for like portals or teleport, but they're a good way of testing a product before you get it out. Upload it, see if anybody buys it. And you don't have to build a Shopify store or a sales channel. You don't have to call anybody. You just have to get a model and upload it and then share it with some friends and see if any of them will buy the thing. And that is such a big proof of if the thing is useful. But sell the thing first. Have a great day, everybody.